Hi, folks. Today on 1 Minute Math, we're going to do the full explanation of the exponent rules that you might see in a pre-algebra, algebra 1, or even an algebra 2 course. So the kind of thing I'm talking about right here would be not exponential functions if you're in pre-calc or calculus, but you might see something on your homework that says like x cubed times y to the fifth times z to the third over x times y to the seventh times z squared. And you're supposed to simplify that. This is the kind of expression I'm talking about. And it basically, the good news is this topic boils down to a finite set of simple rules that we just have to apply. So we're just going to see the rules, figure out why they are what they are, and I'll show you some examples of how we can apply them to simplify or condense expressions. So you probably know this about exponents, that if I said like 3 to the fifth, that means I'm going to multiply 3 times itself 5 times. That's what an exponent does. Repeated multiplication. So the number that's up here tells you how many times to multiply, right? So if I had 0, if I said, here's a number, multiply it by itself 0 times, well, that's really like multiplying by 1, and that's why any number to the 0 power is 1. So if I see any number to the 0 power, I say 1. Even if it's a bizarro number like pi or e or the square root of 17, if it's to the 0 power, you just reduce it to 1. This next one says if I have a to the n times a to the m, I can combine those exponents and make it a to the n plus m. That would be like saying I've got the same base, let's say 2 to the third times 2 to the fourth. If I think about what that means, 2 to the third is multiply 2 by itself 3 times. 2 to the fourth is multiply by 2 by itself 4 times. Do you see how this is really multiplying 2 by itself 7 total times? 3 from the first expression, 4 plus times in the second expression, and I add them all up and I get 7 2's. So that's why I can add those. And you'll probably see this really quickly in a very similar way. Let's say I had 3 to the fifth over 3 to the third. That means 5 3's divided by 3 3's. And now I can cancel them. And you notice that I only have 2 left on the top, and this would be like 3 to the 2. So that's why when I'm dividing expressions with the same base, I subtract their exponents. Now, in a very similar way, that means that if I have a to a negative power, that's like dividing by a to that power. If remembering that, like if I said 3 to the 2, that means multiply 3 by itself 2 times. If I asked you to do 3 to the negative 2, that's really like asking you to unmultiply by 3 2 times. Isn't that really the same thing as dividing? Unmultiplying is dividing. So 3 to the negative 2 really would be like divide by 3 to the 2, or we could say 1 over 3 to the 2. Putting a number in the bottom of a fraction means you're dividing by it. Last rule down here, if I had a power to a power, let's say I have 2 to the 3 to the 4. This is going to be annoying for me to write all out, but you're going to get the idea. 2 to the 3 means 2 times itself 3 times. Okay. Now I'm going to take that whole thing to the 4. That means that whole thing times itself 4 times. Now I've got 3 2's in each of these. How many 2's do I really have? Is 12. So in that way, these rules, this is the end of our rules, and in that way, these rules really do make a lot of sense. So you don't have to memorize them if you can understand what they came from, but hopefully they'll be quick for you to memorize and just learn and apply. Let's see them in action. This first one's so easy. The only thing that I noticed in this first expression at all that I could do anything with is that I have 2 x's. If you see all different bases, by the way, if there are no repeated bases and no parentheses or anything, you're done. If I asked you to simplify x to the third, y to the fifth, z to the seventh, you're done. That's the goal, is to have only one representative for each base. So the only thing that's not combined or not condensed in this case is that I have 2 x expressions, so I'm going to pull them together. Multiplication is commutative. That means that I can rearrange the terms however I want. And now I've got those next to each other. I'm going to remember that that's x to the sixth. 2 x's, 4 x's, 6 x's total. The y is just going to hang on there. And this is my final answer, x to the sixth, y to the third. All right, in my next example down here, I have 2 pairs, 2 groups, one group of x's, one group of y's, and I'm going to simplify each of them. This is both, in both cases, I have a division thing happening, and you remember that means I can subtract the exponents. 4 minus 2 is 2, so my x term becomes x to the 2. And then in the y's, 3 minus 2 is 1, so that becomes y to the 1. You are probably aware that we don't typically write a 1 if it's just the power of 1. So I'm just going to say that that's x squared times y. If you wrote x squared times y to the 1 on your paper, your teacher should give you full credit for that. Now in this one, we've got an example. I put two things together. We've got multiplication in here, but it's not the same base, right? So I can't combine this and make it xy to the 5th or anything. They're not the same base. You can't combine them. But I do have this parentheses, like a power to a power thing happening. So imagine this real quick. I've got x squared times y cubed to the 4th. That means I've got 4 of these. I think you will see pretty easily, pretty quickly what's going to happen. All my x's together, 2 times 4 makes 8. And all my y's together, 3 times 4 makes 12. And that's my final answer for that guy. I could have just multiplied. 2 times 4 is 8, 3 times 4 is 12. As long as I don't try to combine the x parts, the x exponents and the y exponents, we're good there. All right, and here's another fun one. We got maybe 2 more examples here. Actually, this might be, nope, we got a couple more examples. Okay. On this one, I see columns. If you have a problem like this, by the way, let's say your teacher set this up for you where they weren't lined up. Remember that it is just multiplication when you have the things lined up like that. You can rearrange them so the A's are on top of the A's, the B's are on top of the B's. There's one bar there. You can move stuff around as much as you want on the top and on the bottom before you start trying to combine. So I'm just going to subtract in pairs. 5 minus 2 is 3. Ooh, 1 minus 3 is negative 2. And 3 minus 1 is 2. Notice how I put a 1 on each of those? When there isn't an exponent, you can remember that that just means there's one of them. So that's the exponent that you're dealing with is 1. Now I'm not totally done. Your teacher, if your teacher asks you this question, they probably will say something like, use only positive exponents in your answer. So I can't leave this b to the negative 2 there. I can't have a negative 2 on an exponent. That's really not the simplest form. So I'm just going to remember what my rule was, which is that if I see a negative exponent, that means that that term belongs in the denominator of my fraction. I'm dividing by b squared. And that is my final answer. A cubed times c over b squared. I see students sometimes write them this way. And that's totally fine. You can leave a space there so that visually you can see like there was a column for the A's, a column for the B's, a column for the C's. I also know students sometimes see this and are like, oh, 3 is bigger than 1, so the bottom's going to win. Like B's going to end up in the bottom. If you want to skip that step and skip writing the negative exponent, if that makes sense to you, please feel free to do that. Feel empowered to make that jump. All right, a couple more. Now on this one, I threw a number in here. Notice how when we have these parentheses with the exponents, you can treat this like the distributive rule. It is actually a distributive rule. It is exponential, is like powers distributing over multiplication. So I'm going to do 4 to the 2 times a to the 3 times 2, 6 times a to the 5. Now, 4 to the 2, you probably know is 16, 4 times 4. If you didn't know that, you could ask your calculator, or you could just multiply 4 times 4 and change that into a number. And then these guys now I can combine by adding. I've got 6 A's, then 5 more A's, 11 A's. 16a to the 11. That's a wild answer. Let's start this one the same way, kind of distributing. 2 times 2 is 4. Negative 3 times 2 is negative 6. And again, I can't leave that negative in the exponent for my final answer, so I'm going to put it in the denominator, x to the 4th over y to the 6th. And again, I can't combine these any further because one is an x term and one is a y term. So I'm going to resist the temptation to subtract 4 minus 6 and try and simplify it that way. This is our very last example here. This would be the kind of thing I'd put on like a final quiz for this topic if I was having a checkpoint quiz on this kind of stuff. My first thing, I kind of tend to just subtract and then deal with the negative exponents in the end. If you like switching them or trying to figure out, is the bottom or the top going to win, please go ahead and do that. But the more reliable strategy for me is to just take each term, so the x terms, and subtract my exponents. 4 minus 2 is 2. And then I'm going to do the y's. Negative 4 minus negative 3. That's like -4 plus 3. That is -1. So this is going to be y to the -1. And then my last column here, -3 minus 4 is -7. So that's going to be z to the -7. And I'm going to move both of those terms with the negative exponents into the denominator of my fraction. I'm going to make a fraction here, and y to the 1 in the bottom. So I'm not going to write the 1, z to the 7th. That is my final answer for this one. And that's the end of this video. I hope that you found that helpful. Yeah, check back for our next video soon.